completing the square where a does not equal 1. So we want everything on the same side in standard form. So let's go ahead and add 12x to both sides, subtract 18, and we're looking at 3x squared plus 12x minus 18 equals 0. Now we can think about completing the square. First step is our two spaces. So 3x squared plus 12x. Space, space, here's our minus 18 equals 0. So with a value in front of our x squared, we want to factor out that 3. So we're going to take the 3 out, and we're just factoring it out of our first two terms. So we're left with 3 and then x squared plus 4x. Space, space, minus 18 equals 0. Our b over 2, well, our b is a 4, so 4 divided by 2 equals 2. We're going to want to square that, and that gives us a 4. So we add 4 here. We have to counterbalance, but let's remember, here's the trick with this one. When we add 4, really, it's like we're adding 4 times 3, which is 12. Counterbalancing a 12 means we would subtract 12 right here. So we can go ahead and write this completed the square version. We have 3 in parentheses x plus 2 squared, and then negative 12 minus 18, so we have minus 30 equals 0. So to solve for x, let's get the x by itself. We're going to start by adding 30 to both sides. We have 3 times x plus 2 squared equals 30. Divide both sides by 3. That's what's going to get this 3 on the outside to go away. So we have x plus 2 squared equals 10. To undo the square, we take the square root of both sides. X plus 2 equals, now taking the square root of both sides, remember that 2 tells us 2 answers, so plus and minus the square root of 10. And let's subtract 2 from both sides. We're looking at x equals, x equals negative 2 plus or minus the square root of 10. So final thing we want to think about is, will the square root of 10 reduce? Do any of our perfect square numbers fit into it? Since they don't, then we are done with this problem.